My name is Dave Stokes. I am a community manager for MySQL products. I've been doing that for a little bit over a decade now. Time is flying. If you need to get a hold of me, email address is david.stokes@oracle.com. Twitter handle is @Stoker. If you just search for Dave Stokes MySQL, you're bound to find some tangential way to get to me. Before we get going, since I work for Oracle, I have to mention that today I'm talking about the free open source version of MySQL Server and all the rest of our products. I might touch lightly on the enterprise version that you do have to buy a subscription to use. It's free to download for 30 days to evaluate, but after that you have to get a subscription. But if we get off on a tangent on some stuff coming out, and there is a lot of stuff coming out in the next 30 to 90 days from MySQL, please take it with a grain of salt. I don't have perfect knowledge of what's coming out. I'm testing some of the stuff and it's really fantastic, but I can't really promise that it's going to be exactly the way I see it when it gets to your hands. By the way, if you're running MySQL 5.6, last February, it reached its end of life. No more updates, no more bug fixes. Please upgrade to MySQL 5.7 or better yet, 8.0. A lot of good wins by simply upgrading there. By the way, if you want to try MySQL in the cloud for free, you can get $300 worth of credits by going to oracle.com/cloud/free. $300 on the smaller machines will last you quite a long time. Please try it. You'll see some announcements about this coming up very shortly. There's some new features that are really, really amazing. And like I said, here's $300 free. Go try it. So what is this session about? Well, part of my job as an evangelist is I go out there and I read what people are writing, problems they're having, solutions they're offering for MySQL. And very rarely do I ever see anyone complaining about the database running too fast. I've never actually had anyone complain the database is running too fast. So you have a query and you want to make it faster, and you start reading some of the stuff out there on the web. Unfortunately, not the MySQL manual, we read other stuff. And it ends up looking like something like a Harry Potter dark arts where you're waving a wand over a newt's toe and boom, smoke goes off and your query runs faster. No, that's not it. Understanding how queries work is treated as magic, but it's really not. So we're going to be looking today at the proper uses of indexes, histograms. I'm not going to cover the locking options and some of the other ways to speed up. If you go out to slideshare.net/Dave Stokes, I'll give that several times during this presentation. You'll see a much longer presentation than what you're seeing here. I'm limited to 45 minutes thereabouts, try to get it down to 35 to 40. But there's a lot of other good material out there. Now, this is a dry subject. We're talking Mojave Desert, late September dry. Unfortunately, that's the way it is for some technical subjects. I can't make it fun and bouncy. I can't use hand puppets, unfortunately. More probably lack of talent on my side. There's a lot of text on screen. I'm sorry about that. Download the slides from slideshare.net/Dave Stokes. You'll actually find some of this a couple other places for other shows I'm doing. I continue to update the slide deck. So if you see it 2 months from now, they'll probably have a lot more material in there. Don't try to absorb everything at once. See what you can get out of it first and then work with it a little bit and then come back. Instead of giving you a spoonful of medicine, I'm shoving the entire medicine factory down your throat in this very fast presentation. Big advice, work on your most frequent queries first. Something that runs 100,000 times a minute that you save 2 milliseconds off of is a big, big win to pay off there. And then work on the next one. By the way, your optimizations may need to change over time. The query that you have running perfectly today, 6 months from now, when you've doubled your data size, might need some tuning. Also today, I'm not going to cover system configuration. I'm not going to talk about what you can set your OS to or the MySQL server to for optimal performance. That's kind of in itself a one-week tutorial. Not going to talk about hardware. Hardware is a real messy subject, and no two sites seem to have exactly the same stuff, even in the cloud, which is kind of scary. Also, I'm not going to talk about networking. By the way, if you ever had an LDAP and a DNS zone update while you're trying to do replication between servers, it's not a pretty thing. And once again, the slides are at slideshare.net/Dave Stokes. Also, I'm not going to cover normalizing your data. This is where you take your data and organize it so you have no or minimal redundancies. If your data is not structured right, it's like building a skyscraper on a beach where the waves are coming in and the wind's eroding the sand behind you. I recommend you use third normal form or better. I have modified this past couple of years saying use a JSON column for stub data. You have a 1 gigabyte payload there. You can denormalize a little bit where it makes sense. But you have to also think about how you're going to use your data. How you want to pull the data out actually says more about your structure than how you actually put it in there. You can't really eat soup very well with a fork. And by the way, badly normalized data will hurt your performance. Third normalized form or better, the math does work out. It does make your queries faster over time. And no matter how much training you give it, a dachshund will not outrun a thoroughbred horse over a mile. So the main thing we're talking about today in and about it is the optimizer. And Wikipedia says it's the brain and nervous system of the database. And it wants to take your query and optimize it to be able to pull back your data efficiently. Ugh, been a long day. One of the hardest problems in data in computer science and databases is how to estimate the cost of your data. A long time ago, most of the databases came up with the idea of coming up with the cost of disk reads. Read from disk is 100,000 times slower than from memory. Big win if you can pull something out of memory. Databases love memory. So the optimizer has a mathematical model depending on that cost to try to pull back your information. And it has that information through detailed statistics. As everyone can tell you, statistics have problems. Like a GPS, the cost is built on historical information. Like if I want to go to my favorite restaurant, left out of the driveway, right at the stop sign, over the railroad tracks, and my favorite restaurant's on the right. Unfortunately, I don't know that my neighbor has blocked my driveway. The train tracks are being torn up for construction, and the restaurant has decided to move across the street. So my historical information does me little to no good. Optimizers like that. If it has bad information about where your data is or incomplete, it's going to make a bad query plan, which means things are going to be slow. By the way, MySQL wants to see each query every time and try to optimize it. There's no locking down the query plan like you can in Oracle or some other databases. A little bit later, if you go through the slides, you'll see something about optimizer hints. I can't cover that today, but it's a way to kind of give hints to the server about what you want it to do. By the way, say like you're joining 5 tables, which is fairly common. That's 5 factorial options, or 120 different options that the server can do. Oh, by the way, that's my dog Boo back there. You might see another little brown one. That's Mac. They very rarely comment. Explain. Explain is usually the only way you're going to find what your optimizer wants to do and give you the query plan. Now, the explain syntax, if you go to the MySQL manual, which is in chapter 8, tells you how the server wants to process your query. And you can see here, there's a lot of different options. You prepend the word explain to a select, delete, insert, replace, or update statement. By the way, explain has several varieties to make things even more complex for those of you starting off. And if you are just starting off, there's a lot of varieties out there. Just do the best you can. Now, here's a simple example. We have a query. Select star, which is the wildcard for everything, all the columns, from the table named city, where the country code column has the value of GBR. And by the way, in MySQL, the \G gives you a vertical readout instead of the horizontal tabular readout. So there's our query. The details for the query, what it's going to think it wants to do to get the information, and then the actual query plan. You notice the query plan is kind of like our query, but the optimizers added a couple things for us. Now, if you're a little more visual with MySQL Workbench, you can get some of this information with visual explain. There's explain format equals tree, which gives us more information. Now, this is a slightly different query where we're actually joining 2 tables together and we're hooking them up where the city.population is equal to the country.population information. And it tells us in this case, we're running an inner hash join. That's one of the 2 join types that we have. And you'll see that those can be a lot faster than our standard nested loop. For those who want even more information, format equals JSON. And it gives you all sorts of information, the rows examined, the read cost, the columns used, a whole bunch of other stuff, how it's joined. For those starting off, this is overkill. For those who've been doing this for a while, there's some valuable information in here. Also, about a year ago, added explain analyze. All those other explains used historical information. Whatever the system was able to glean from the past executions. When you run explain analyze, it actually goes out and runs your query. So be careful if you have a real nasty query when you explain analyze. But it actually comes back and tells you the actual time it took and the number of rows it had to read and the number of loops it had to run. So we'll use a little bit more on explain later, but I wanted to kind of give you a general overview of how we get to query plan. So what is an index? Well, according to Wikipedia, a database index is a data structure that improves the speed of data retrieval. Well, how does this happen? Well, you have to create an index, and I tend to think of it as creating a smaller stubby table that points to the bigger table. And by the way, that table, that index table should also be in memory next to the data table. And the more memory you have, the better, because if it has to move things in and out, it can be painful. And also, the more memory you have, the better, because remember, memory is 100,000 times faster than a disk read. And of course, to make this even more difficult, there are many types of indexes. If you look at the manual page, you see that we have create, index, index name with options of unique, full text, spatial, some other things you can do with it. Now, MySQL uses what they call a clustered index, and the table is organized based on the value of the primary key. And for best performance, choose a primary key carefully. You'll get the best performance out of that. By the way, modifying a primary key or replacing it with some other field is very costly. And if you're an Oracle type person, this is better known as an indexed organized table to you. So we have this little, what I call stubby index table that has the pointers to our data table. This is the way I think of it. It's not really the way it works behind the covers, but it's kind of a good conceptual overview. Now, if you have a secondary index, so you already have your primary index and you index something else, the secondary index is kind of cheat because they just have a pointer to the primary index. So there's really no extra magic to a secondary index. So let's create a simple table. Create table T1. By the way, you'll love my table and column names. Column 1, int, not null. We'll talk about null later. Auto increment, that means every time we insert a record, it's going to bump that integer value by 1 or some other preset increment. And we declare it as primary key. And then we have 2 other columns. Now, an index is a list of keys. And in the MySQL world, you'll hear key and index used interchangeably. We also use database and schema interchangeably. Got to apologize for that. That's just our common usage. Now, the primary key is a key for the index that is uniquely defined, hopefully uniquely, and it should be immutable. I mean, don't go around changing it. InnoDB requires a primary key for proper efficiency, and if you don't specify one, it will make one up for you, and it's almost guaranteed to be the wrong one. By the way, I recommend not using null values in there. And by the way, if you're a fan of UUIDs, they do not increase monotonically. That means they don't go by 1 or some preset increment. If you have to use UUIDs, please use our UUID to bin function. Otherwise, avoid UUIDs if possible. They're not efficient with MySQL. Now, if you have some data that, say like a last name, sometimes you get away with not indexing all of it. In this case, we're going to create an index, part of name on a table called customer, and we're going to take the name column and index just the first 10 characters. Now, if you live in a country that lets you have names that are longer than 10 characters, and you can kind of get in the ballpark with 10 or less characters, this is a good option. Also, you can have multiple columns in an index. In this case, we have a table where we have a column called ID, which will later make a primary key. We have a last name and first name, and we're indexing, creating an index called name on the last name and first name. Now, this index will work on searching for last name and first name and last name, but not first name. Its usage is left to right. Put the highest cardinality first. And by the way, sometimes you can have indexes that will hold all the data you need to return, and you don't have to dive in the data to get all the information from an index. We'll talk about that in a little bit. And sometimes you have values that just don't quite work for indexing. And one thing you can try is hashing the values. In this example, we have value 1 and value 2. We're going to concatenate them together, and then we're going to do an MD5 hash. I've used this before in parts assemblies where maybe it's a model number and a serial number, put them together, and it ends up being a better alternative than trying to search by the other two. And of course, MySQL gives you even more options. Unique indexes where there's only one value per row. Full text searches for doing searching for strings for certain combinations of letters and numbers. Covering index, that's where your index has all the information you need. In my case, first name, last name, zip code, and patient number. My doctor, I call it, they want first, last name, and zip code, and it will pull up my patient number for them. So that saves them a little bit of time diving into data. Talked about secondary indexes already. Spatial indexes. If you're writing your own Google Maps or something similar, you can type in, okay, I need to know if this point is within this piece of geometry, and it can tell you. Oh, I had someone in the chat. Let's see what it says. Is MySQL just using a hash table under the hood to store all the data? No, it is a full relational table. Now the JSON stuff is basically a blob, but it is not a hash table. Okay, let's get going. Functional indexes. This is something that's kind of neat. You can actually have some sort of computation to create your index. The first one, creating a table T1, we have something called call1 that we're using the absolute value of that to get a value. This might be something that is temperature and you don't care whether it's plus or minus. Something you do is maybe you have, like in this bottom one, you have a 40% overhead you got to charge for cost value. There's all sorts of other complicated analysis or calculations you do to create indexes there. Multi-value indexes. In the past, you could not have more entries in an index than you had in the actual data table. Well, with the JSON data type, people started using that because it has an array type, and MySQL does not have a native array data type. So what we had to do is come up with a way to have more index entries than there are actually rows of data, and that's our multi-value indexes. In this example, we're looking to see if the value of 3 is a member of this array, and if it is, it returns a 1. I got another question. Let's see. This similar to include columns for SQL Server. Unfortunately, I haven't played with SQL Server in many long years, and I couldn't answer that. I'm sorry. Thank you, Ray, for that question. Okay, MySQL has two types of indexes. The first is a traditional B tree. Actually, it's a B plus tree. So if we're looking for a value of, let's say, 78, we know we have to take this node down to here and then have our pointer to our data. We also have hashes, which is where you basically union two tables together and pull out the needed matches there. This is about a year old in MySQL and works very, very fast if you're doing what we call equijoins, where you have value X is equal to value Y. Now, please keep in mind, if there's a choice between multiple indexes, MySQL's heuristic is that it tries to take the index that's the smallest number of rows, hopefully the most selective. Sometimes that isn't the right answer, but that's kind of the rough heuristic, and you can override that a little bit. Also, if you're doing comparisons, make sure you're doing comparisons on similar things. For example, here, if you're doing a var 10 and a car 10, they're both roughly character data and they're both size 10. But if you're doing a car 10 and a car 15, machine has to do some extra calculations for you to get that there. Cars and integers, there's some casting that has to go on, and all that casting and all that kind of slows you down, and it has to be done for each row. And if you can avoid it, please do. Okay, null. This is an interesting subject. The original idea back in the punch card days is that you had one bit of data. If it was true, it would be 1. If it was false, it was 0. And then people say, well, how to record that we don't know what the value is? And they came up with the idea of null. The trouble is, if you have just 1 bit, you just can't do null with 1 bit. You can do it with 2 bits, either the null's on or null off. And this is a cute representation of the idea of null. Now, the trouble with nulls is basically they're not a value. So if you have a whole bunch of values you're searching through and you have nulls in there, everything is screaming along until it has to go through the junk drawer full of nulls to search for the matches, and that slows things down. So if you can avoid using nulls in a in a index column, the better. Now, something they added with MySQL 8.0, which is now coming up on its 3rd anniversary, is invisible indexes. In the past, oops, got another Q&A up here. How does the full text search work? I don't have a text analyzer chains, or does it do tokenization? I believe it's text analyzer chains. It doesn't do tokenization to my knowledge. The idea is it takes your text and creates an index into that. So if you're searching for THE, it has a bunch of things that start with THE. You type it in R, it knows, oh, it's going to be there or something similar, and it kind of changes down through that. I'm sure my engineering friends are laughing at me about that bad description. Okay, before invisible indexes, you were running explain on a query, and one of the indexes that was a possibility, you're not sure if it was a good one. So you doubt the usefulness of that index. You check it running explain, you're still not sure if it's good or bad. You remove that index and you rerun explain. And as you're rerunning explain, you get a phone call, a text, or a scream from a PAL user about how suddenly their query has turned to glacial progress. Well, then you suddenly realize that that index may not be good for your query, but a lot of other people are waiting for that index and really need it. So you have to go out and rebuild that index, which can take quite a long time, unfortunately. Now, after invisible indexes, you doubt the usefulness of the index, you check the query running explain, you make that index invisible. In other words, the optimizer cannot see that index. It's like you've thrown Harry Potter's invisibility cloak over it, and it may be there, but the optimizer can't see it. You rerun explain, you get a phone call from the power user, and you basically make the index visible again. And then you can blame the problem on the network, JavaScript, GDPR, Slack, or the cloud. I got another question. Let's see what I can do. Oh, that's the last one. Okay, SysSchema is very interesting and helpful, especially if you turn on MySQL Workbench. It will give you a lot of this information. It will tell you what indexes have not been used in a while. The trouble here is that the data is only good from the last reboot. So if you reboot it on Monday, you have an index that might be used maybe once a week or once a month or once a quarter. And that might be a very valuable index. So if you have an index that you shows up on this list and you think it's a candidate for removal, make it invisible for a while, good 6 months to a year before blowing it away just in case. How do you use an invisible index? Alter table, in this case T1, alter index in the index name and make it invisible. Now the optimizer can't see it. I want to turn it visible again. You just do alter table with invisible at the end. Okay, on to histograms. Well, histograms are also something that came out with MySQL 8.0, and no, it's not a gluten-free, keto-friendly biscuit. It's actually a measurement. This is an example of a histogram. Someone went out and measured the height of 10,000 US females in centimeters, and they created this lovely little bar chart. Think of each one of these vertical bars as a bucket full of data. So Wikipedia says a histogram is an accurate representation of the distribution of numerical data. For relational database management, a histogram is an approximation of data distribution within a specific column. What that does is, once the optimizer knows how the data is laid out in the column, it can find the data much more efficiently. And I have a good example coming up. So we have two types of histograms, singleton and equiheight. And think of these as buckets with a maximum of 1024 per column. Now, a singleton is a single value in there, like 15. Equiheight is where you have 10 buckets and you put 10% of your data into each bucket. Now, histograms are primarily useful for non-indexed columns and data that does not churn. A histogram can be created on demand, so you can put it into a cron table to run when things are quiet. It doesn't have overhead the way an index has. And the statistics are very, very good for the optimizer. Now, why would you use a histogram instead of an index? Well, maintaining an index has a cost. Anytime you do an insert, an update, or delete, that means the index as well as the data has to be updated. And on busy systems, this can get very, very expensive. By the way, from time to time, the optimizer will take index dives to double check the statistics. In some cases, this can become very costly, and it often happens at the worst time when you're trying to crank out something on a Friday afternoon for payroll. Now, occasionally the optimizer fails to find the most efficient plan and ends up spending a lot of time executing the query than necessary. Now, the optimizers assume that the data is evenly distributed in the column, which is sometimes true, but often not. The optimizer just doesn't know how many good rows are in each table, how many distinct values are in each column, and how is the data distributed. It's going to assume that everything's distributed evenly, which is not often the case. As I mentioned earlier, we have two types of histograms, the equiheight and the singleton. Equiheight is you're dividing up the third grade class with all the people whose last names begin with an A to G in one row, H to L in the next, M to Z in the next. Singleton, I have a good example of that coming up in just a minute. So let's take a look at a histogram and take a look at the frequency. We have three possible values, 101, 102, and 104. Have no idea what happened to 103. We're going to insert into a table called frequency histogram, 2 101s, 3 102s, and 1 104. And when we looked at our data, there's our 2 101s, 3 102s, and the 1 104. And we create a histogram on there with 3 buckets. So all the 101s are in one bucket, et cetera. So if we take a look at our information schema on the statistics, we can find out what the histogram looks like. We know that 33% of all data is going to be values in the first 101 bucket. We know if you look at 101 and 102 together, that's 83% of your data. And if you look at 103, 102, and 104, that's 100% of your data. And if you look at the cumulative frequency, you see 101 is 33%, 83% for 102, and 104, if you're getting all the values up to 104, you got 100% of the values, even though the frequency is not as impressive with the cumulative frequency. The optimizer knows where the data is. So how do you create a histogram? Well, you type analyze table, update histogram. In this case, we're going to create histograms on columns C1, C2, and C3, each with 10 buckets. We work with the data, realize it needs updating. You run analyze again and update the buckets on C1 and C2. And to get rid of the bucket on C2, we can do drop histogram. Now, these are 3 different histograms with 3 different uses. You can get information from the histograms from the information schema. I can tell you the data type and the number of buckets that you're using. Now, here's an example of where histograms really shine. And you'll have to indulge me here. This is probably not the easiest explanation out there, but it does work. So we're going to create a table called H1, which has a ID column and a column called X that's an integer. So we're going to insert 2 1s, 3 2s, and 4 3s into our table. And if we do a count of those, 2 1s, 3 2s, and 4 3s. Now, without a histogram, and we run a query that says, okay, select everything from H1 where X has a value greater than 0. The optimizer has some information, but it doesn't have really good information. So this filtered column here is its estimate of the percentage of rows it's going to have to read. It knows it has 9 rows out there, and it's guessing it's going to have to read at least a third of those. Well, imagine that's trips to the grocery store or other trips you have to do. It's going to tell you, yeah, I can do that. I can get all that with 3 out of 9 trips. Now, this is kind of a rough estimate, but it is kind of a good thing. But remember here, it thinks it's going to have to you're going to have to read 33% of our 9 rows. So let's create a histogram with 3 buckets. And this time when we run the same query, select star from H1 where X is greater than 0, it now knows that it's going to have to read all the rows of our 9 rows to get all those values, where before it had a rough idea of how much it had to read. So this was able to grab things and give us a better estimate. So instead of saying, I can do this in 2 days, it knew it could actually do it in 4 days. I'll skip over that. Now, performance is not indexes and histograms. There's lots of other things out there. When you use Explain, you'll see things like file sorts. This is where your data has to actually be written out to disk or in memory and sorted. Full table scans. This is the entire data table has to be read. If you're doing something like quarterly reports or monthly invoices, you have to go from the front to the back anyway. Usually you don't want full table scans. Seeing full table scans means you may not have a proper index or any indexes at all. Temporary tables, which are vastly improved in NATO, that's another thing that can slow you down. After a while, you get used to a database and you can tell if the join order looks right. And sometimes the optimizer just does not do that. And then there's the more systemic stuff. Are your buffers and caches big enough? Do you have enough memory? Is your IO fast enough? Are your disks or disk-like devices keeping up with your need? Now I'm going to skip over a lot of these things, unlocking options and other ways to speed things up, because they're out there on the regular slides, but I wanted to leave 10, 15 minutes for Q&A. By the way, the full slides are at slideshare.net/Dave Stokes. On other things you can do, like resource groups, using multi-value indexes, optimizer hints, and partitioning. Now, if you're really interested in this and you want to play with it, I highly recommend reading the MySQL manual, probably the best single source. By the way, between releases, we do update this, so there might be stuff in there that's new. It's worth a reread on a regular basis. If you have questions, we have forums at forums.mysql.com. Our engineers take a look at that on a regular basis, so chances are you can get a really A+ answer if you're a little bit patient. Also, I recommend highly joining mysqlcommunity.slack.com. You are part of the MySQL community, so please join in. Our engineers really monitor this. Great place for information on MySQL and a lot of valuable information out there. Now, here's 2 books I recommend. I highly recommend this author, Jesper Wisborg-Crowe. He used to be MySQL support. He's now off at another company, but he writes very well, explains things very easily for highly detailed subjects. I reread these books on a regular basis, and I find more information every time. You do need these books. All his other books, like the one on the Python connector, are absolutely amazing. I recommend buying everything of his. Now, this is another book that I kind of hesitant to recommend. The 3rd edition has been out for several years. It's getting dated. You can usually find it in used bookstores. Make sure you get the 3rd edition. The 1st and 2nd editions are very, very old. Supposedly a 4th edition is in the works, and I do not believe the original authors are involved, but it has a lot of good explanations about how a lot of things work at the lower level of MySQL. Now, if you're using the JSON data type and can't make heads or tails through the documentation, please buy a copy of my book. It's available on Amazon. 2nd edition came out a couple months ago. Lots of programming examples and best practices. This is a book that you can sit down with no knowledge of JSON and be able to use it with a relational database or a NoSQL document store, the MySQL NoSQL document store, very easily. And the 2nd edition, in the 2 years since I published the 1st one, I was able to add twice the material. I'm getting more material, and I'm not being coerced yet to do a 3rd edition, but that might be 2 or 3 years down the road. Also, if you are in a startup, I have a deal for you. I'm one of the startup ambassadors. If you go to oracle.com/startup, there's a lot of stuff that Oracle wants to give you. Discounts, we can give you some marketing exposure. We invite you to events to show off what you're doing and help promote what you're doing. There's some mentorship and exposure to almost 500,000 Oracle customers. And it's free to join and has a lot of great stuff there. And with that, if you need to get a hold of me, I'm david.stokes@oracle.com, @Stoker on Twitter. I have a PHP related blog, elephantdolphin.blogspot.com. Dolphin is the MySQL mascot. Elephant is the PHP mascot. If you're looking for the latest MySQL blogs to see what's going on with the MySQL world, planet.mysql.com. Once again, we have the forums, and I highly encourage you to go out to mysqlcommunity.slack.com and join there. And once again, these slides are on slideshare.net. And let me go out to the Q&A. And
that was awesome. Thank you, Dave.
Okay. I think we got everything. Well, thank you for having me, and thanks for hosting me. And this is a wonderful show. Hopefully we'll be in person next year. And once again, I want to plug the October show. Todd and his crew do an amazing job every year. Jennifer Suber, who's his right-hand Majordomo does an amazing job handling me because I'm always forgetting stuff. And ooh, here's some more questions in the
I see a
chat.
question. I don't know if, yeah. I
Great
see.
talk. Thank you very much from just as the first three letters. Well, hopefully we'll be, our index is stored in an object file or separate files. They're actually stored with the data, but I really couldn't give you a decent explanation in under 25 minutes and a whiteboard and some very misleading drawings. If you really, really want to know, go out to the MySQL community and ask someone where the layouts are. They can point you to it. By the way, the source for MySQL is out on GitHub. So if you want to work with that, it's out there. And thank you, Ray, for saying, thanks, David. I appreciate the guidance on this. We'll be exploring this in detail. Well, thank you all for turning out. I'm the last talk in the session. I think we have to stand by for the prizes and giveaways. And I think that's it for me.
Thank you, Dave. Yeah, I think I see a question in the Q&A. How does the full text search work? Does it have text analyzer chains?
I think it's text analyzer chains, but it might be tokenization. I'm not really sure. I think it's more text analyzer. I don't play with the in the bits anymore.
Okay.
Okay, folks. Well, if that's it, or you're too shy, send me an email or hit me on Twitter.